Hello everyone, welcome back to my channel. This is Ashwini from Sri Venkateshwara College of Engineering. So today we are going to talk about various topics in NoSQL. So first we'll see what is distribution models. The primary driver of interest in NoSQL has been the ability to run the databases on larger clusters as the data volumes increase and it becomes more difficult and expensive scale up by the bigger services to run the database on. A more appealing options for scale out run databases clusters of services. So, depending on your distribution model, you can get a data store that will give you ability to handle the larger quantities of data and ability to process this greater read-write traffics. So, or the availability in the face of network slowdown breakages. Running over a cluster introduces the complexities, so it's nothing to do you unless the beneficial compelling broadly. There are two types of data distribution: replications and sharding. This we'll see next. So next is single server. The first and simplest distribution option is one we would most often recommend. So no distribution at all. Run the database on the single machine that handles all the reads and writes of this data store. So we can prefer this option because it eliminates all the complexities of that other options that introduce. So it is important and easier for the operations people to manage and easy for the application developers to reason about. Although there are a lot of NoSQL databases that are designed around the idea of running on the clusters, it can make the sense of NoSQL with single server distribution model and data model for the NoSQL store. So for the rest of this chapter, we'll be wading to the advantages and complications of the sophisticated distribution schemes. So don't let this volume words fool you thinking that we can prefer these options. So next is sharding. Sharding is often a busy data store that is because different people are accessing different parts of the data sets and the circumstances we support for this horizontal scalability and putting different parts of this data onto the different servers. So in this ideal case, we have different users talking of different server nodes and this huge user only talk to the one server and gets rapid responses from that server. The load is balanced out nicely between the servers and for example, if you have 10 servers, each only has only one to handle 10% of this load. Of course, the ideal case is pretty rare beast, but in order to get close, if we have to ensure this data of that is access to the complex of some node and these bumps clumps are arranged and nodes of provide the best data for the part of questions how clumps of the data so that user mostly gets data. So next is master-slave replications. So with master-slave replication distributions, you can replicate the data access of the multiple nodes and one node is designated as the master or a primary and this master is authoritative source for the data and usually responsible for processing any updates of this data and another nodes of the slaves or secondaries. So the replication of this process synchronizes the data slaves with the master. Master-slave replications are most helpful for scaling and when you have a read-intensive dataset, you can scale horizontally to handle more read requests by adding more slave nodes and ensuring all the read requests are routed by the slaves. So consequently, it is such a good scheme for the data sets with heavy write traffic, although the read traffic with the help of bit handling the write load. The second advantage of this master slave is to read resilience. Should a master fail, or the slave still handles the read request. So next is peer-to-peer applications. So in the master-slave replication, it helps to read the scalability but does not help in scalability to write. It only provides resilience against the failure of slave but not a master. Essentially, the master is still a bottleneck and a single point of failure. Peer-to-peer replication attacks are the problems for not having the master on all the replicas that is equal to the weight and all accepts the right and loss. The prospect that looks might fine, but with the peer-to-peer replications clusters, you can only ride over the node failures without losing access for the data. So when you can write the two different places, you can risk that people will attempt to same record at the same time and write conflict. So next is combining the sharding and applications. So replication and sharding are the strategies that can be combined if you use both master slave or replications and starting. And if you means that if you have multiple masters but the data items only have single master, depending upon your configurations, you may lose to the node before the master of same distance and slaves of or other may dedicate for the master and slave duties. Using peer-to-peer replication and sharding in common strategy for the column family database in scenario like this, it might have 10 and hundreds of nodes in the clusters with the data sharded over them. A good starting point is peer-to-peer replications that have the replication factor of 3, so each shade present on the 3 nodes.